How can electromagnetic interference corrupt data? Imagine your computer or device is like a busy highway, with data packets zooming back and forth. Now picture a sudden gust of wind or a loud noise disrupting those cars. That's similar to what electromagnetic interference does to data. It's a sneaky form of noise that comes from outside sources and messes with electronic signals. When electromagnetic interference, or EMI, occurs, it introduces unwanted electromagnetic energy into circuits. This energy can cause the circuits to behave unexpectedly, leading to errors in data storage or transmission. In simple terms, EMI can cause bits, those tiny pieces of data that are either a 0 or a 1, to flip from 0 to 1 or vice versa. These bit flips happen during data transfer, when data is stored in memory, or while the device is processing information. For example, in memory chips, EMI can induce voltage changes that flip bits, which can change the stored data. This might cause software errors or even system crashes. When data is sent over cables or wireless links, EMI can distort the signals. This distortion can lead to lost data packets, corrupted information, or complete failure to receive data correctly. This is especially problematic in places like data centers or communication networks where reliable data transfer is essential. EMI sources are everywhere, from natural events like lightning and solar flares to everyday electronic devices such as microwaves, computers, and even power lines. Industrial equipment and wireless transmitters also contribute to electromagnetic noise. Cables are particularly vulnerable because they can act like antennas, both radiating and picking up electromagnetic noise. This makes data transmitted through cables more likely to be corrupted by EMI. From a troubleshooting point of view, it's important to remember that some data errors might not be software bugs but hardware issues caused by EMI. Detecting and fixing these problems involves several strategies. One method is data mirroring, where two copies of data are stored, one normal and one inverted. Comparing these copies helps find inconsistencies caused by bit flips. Error detection techniques like checksums and parity bits are also useful. They help identify corrupted data so it can be corrected before causing bigger problems. Hardware solutions include using shielded cables, proper grounding, and filtering components to reduce EMI susceptibility. Good circuit design practices also help prevent interference from affecting sensitive parts. Tools like electromagnetic interference analyzers can predict how EMI might impact a circuit, allowing engineers to make adjustments before problems happen. In summary, electromagnetic interference corrupts data by creating electrical disturbances that change bits in memory or data signals. These errors can lead to software bugs or system failures. Recognizing EMI as a possible cause and applying both software detection methods and hardware safeguards can keep your data safe and your systems running smoothly.